I'll tell you what is, though, inverse trigonometric functions. Here we go. And today, in this video, we're going to be talking about the inverse sine function. In the last video, we just covered the inverse cosine. Okay? So, the first thing we want to do is let's look at a graph of f of x equals sine x. And let's talk about what we're doing here. So, we need f of x, again, let's, like we did in the last video, let's say f of 2 pi. F of 2 pi, well, the sine of 2 pi is what? The sine of 2 pi is 0. Okay? So you might want to say, well, that would mean that f inverse of 0, since the inverse function takes the function and sends it back home, you'd say, well, Larry, what is O? Well, f inverse of 0 equals 2 pi. Okay? And then I would say, well, why is f inverse of 0 not 0? Or negative 2 pi? Or 4 pi for f inverse of 0 for f of x equals sine of x? Well, and so that's our issue. And what we need to do is restrict f of x equals sine x to a specific domain where the function is 1-to-1. We need a 1-to-1 function if we're going to have an invertible function. Okay? And mathematicians, scientists, engineers over the years have agreed that we restrict it to this domain here. Okay? We restrict here to have the invertible function, and that is a negative pi over 2 to pi over 2. So we restrict f of x to the domain of f is going to be a negative pi over 2 to pi over 2. And that is going to be the domain of our function when we talk about, hey you guys, please settle down. Again, I'm on kid duty today, but I still got to get these videos pumped out. Okay? So we've got, let's see, where are we at? We're going to do f inverse of 0 again. F inverse of 0. Okay? Now, if we're looking at where my function f is restricted to the domain negative pi over 2 to pi over 2, then this couldn't have been the answer. That couldn't have been the answer. This one has to be the answer. That is, when is sine theta equal to 0, where theta is bigger than a negative pi over 2, but less than pi over 2. Okay? And if we look at our graph here, it's clear that that is at 0. Okay? So note that 2 pi is wrong. The negative 2 pi is wrong. There's only one answer for the f inverse of 0 when f is the sine of x, and that is, the answer is 0. Okay? Let's formalize this a bit. Here's our formal definition of the arc sine of T, denoted with the inverse sine notation here. It's a unique angle from negative pi over 2 to pi over 2 whose sine equals t. So let's say we're doing the inverse sine of root 3 over 2. Okay? So this is telling me that I need an angle here. So we're on the unit circle. I need an angle between negative pi over 2 and pi over 2, where the sine value is root 3 over 2. So that's going to be somewhere up in here, so that's going to be that angle there. Right? And so I think we're going to get that that is pi over 3. So that is the inverse sine of t equals theta means that theta is a unique angle in negative pi over 2 to pi over 2 such that sine theta equals t. So to check, sine, oops, that should be pi over 3. Sine of pi over 3 equals, so yes, here we have the sine of pi over 3 equals root 3 over 2. How are we looking at? Plenty of time on this one. So let's say the inverse sine of, what do we want to do here? The inverse sine of 1. Okay? So I need an angle between negative pi over 2 and pi over 2, an angle between here when the sine equals 1. That is, so when the sine of theta equals 1, so sine of theta equals 1. Well, that is going to be here. So inverse sine of 1 equals pi over 2. Okay? A couple problems set up here on the next page. Inverse sine of 0. We just done that one. So let's do it one more time. Inverse sine of 0. Again, I'll make a unit circle. And for the inverse sine, I'm on this half over here. And when is the sine equal to 0? Well, that's going to equal here at 0. Okay? Number 2, the inverse sine of negative 1. Okay? Let's make a circle. And for inverse sine, I'm always on this piece over here. Okay? And when does my sine value, where is my y coordinate at negative 1? That is precisely right there. So that is going to equal negative pi over 2. Okay, explain why inverse sine of negative 3 makes no sense. Number 3. Inverse sine of negative 3 makes no sense. That's because negative 3 is not in the domain of the arc sine, or you could say negative 3 is not in the range of the sine. Okay? So we're looking 2 minutes. Let's do one more problem. Let's say we've got, let me add a page here. Let's sketch an angle. Let's say inverse sine of 0.7. Okay? Sketch the radius of the unit circle corresponding to theta. Okay, here's a so the inverse always spits out an angle. So inverse sine of 0.7 is some angle such that sine of theta equals 0.7. And so this is just a question to make sure that we understand what we're really talking about. Okay? Let me make a nice circle this time. There we go. And so we have that the inverse sine is of 0.7 equals theta. So that means that the sine of theta equals 0.7. Oops. So that means theta is an angle such that when we sketch the radius, its y coordinate is 0.7. So somewhere up in here. Okay? That's the y, where you get the y coordinate, so you march right along over here. And so that's going to be where the radius is drawn. So that would be a sketch of the radius of the unit circle corresponding to theta, where theta equals the inverse sine of 0.7. Okay? Now, how are we looking? Let's leave it there real quickly. You might also want to say that you could go over here and get it, but you can't, because the inverse sine must be on this arc here. So the only correct answer would be that radius there with that theta that is between pi over 2 and negative pi over 2. So let me cut this off. Next video is the inverse tangent.